In this session, we are going to discuss one very important topic from quantitative aptitude, that is on equations. In almost all the questions that we solve from quantitative aptitude, some conditions are given to us. We are supposed to understand those conditions and get the required answer for the question. All these conditions can be framed in terms of equations, and then those equations can be solved to get the required answer. So in this topic, we are going to understand how to frame the equations and how to solve different types of equations to get the required answers. Generally, equations are classified into two types: linear equations and quadratic equations. We also have other types of equations like cubic equations and so on, but bank examinations point of view, only these two are important, that is linear equations and quadratic equations. A linear equation is the one in which the highest power of the variable is 1. And a quadratic equation is the one in which the highest power of the given variable is 2. So in this session, we are going to discuss how to solve these two types of equations and get the required answers. Let us now take the first module from this topic of equations, where we are going to learn about linear equations. Let us first understand what is meant by a linear equation. In a linear equation, the power or degree of the variable or the variables is 1, and it does not occur in any other powers. So as we can see from this, a linear equation is the one where the degree or the power of the variable or the unknown is 1, and it does not occur in any other powers. The general form of a linear equation is ax plus b equal to 0, or it can be taken as ax plus by equals to c, or ax plus by plus cz is equal to d, where x, y and z are the variables and a, b, c and d are the constants. Remember friends, variable is nothing but the unknown value which has to be determined. So x, y and z that we see in these three forms are the variables or the unknowns which have to be determined, and a, b, c are the constants which are already given. For example, this ax plus b equal to 0 is a linear equation. As you can see here, this is a linear equation in only one variable, and that is x. Similarly, ax plus by equals to c. This is a linear equation in two variables. The two variables here are x and y. And this equation ax plus by plus cz equals to d is a linear equation in three variables, x, y and z. And a, b, c, d are the constants. So as you can see, in all the three cases, that is a linear equation in one variable, a linear equation in two variables, and an equation in three variables, the highest power or the power of the variables is 1. This is x power 1. Similarly, here it is x power 1 and y power 1. X power 1, y power 1 and z power 1. So such equations where the highest power of the given variable or unknown is equal to 1 are referred as linear equations. Now, an equation in only one unknown can be directly solved. For example, to solve a linear equation in one variable, we just need to have only one equation. But when we have a linear equation in two variables, or when we have to solve for two unknowns, we need to have two different linear equations. So here, to solve for x and y, we need to have two equations in terms of x and y. Similarly, to solve for three variables, we need to have three different linear equations. Let us take some examples to understand this. For example, 4x minus 12 is equal to 0. And as you can see here, this is a linear equation in only one variable, in the form of ax plus b is equal to 0. Now, as I've already mentioned, to solve for only one variable or only one unknown, we need to have only one equation. And that equation here is 4x minus 12 equals to 0. And we know that solving such equations is quite simple. What we need to do here is take everything on the other side, that is the right hand side, by changing the sign and try to find out the value of the variable, that is x. So as you can see here, when 4x minus 12 is equal to 0, we can say that 4x is equal to 12. And from this we can say that x is equal to 12 by 4, that is 3. So the value of x or the value of the variable or unknown here is equal to 3. So to solve for only one variable or one unknown, we need to have just one equation. So simply by taking everything on the right hand side, by changing the sign, we can get the required answer. So the value of the variable here is equal to 3. Now x equals to 3 here means that this is the value which when substituted in the equation will balance the right hand side. For example, when x equals to 3, we get 4 into 3, 12. 12 minus 12 is equal to 0. So the unknowns that we determine by solving the equations are nothing but those values which when substituted in the equations will balance with the right hand side. Now let us take another example where we have two equations in two variables. The first equation here is 3x plus 2y equals to 13, and the second equation is 5x plus 3y equals to 21. So as you can see here, these are two equations in two variables. The two variables are x and y. And as discussed earlier, to solve for two unknowns or two variables, we must have two equations. So by solving these two equations, we can find out what are the values of x and y. And you can observe that both the equations are in the form of ax plus by is equal to c, where x and y are the variables and a, b and c are the constants. So 3 is the constant, 2 and 13 is a constant here. Similarly, in the second equation, a is equal to 5, b equals to 3 and c equals to 21 are the constants. So let us now understand how to solve these two equations in two unknowns. Now to solve two equations in two unknowns, we have to eliminate either the first variable x or the second variable y. And to do that, the coefficients of the variables in both the equations have to be equated. For example, let us try to eliminate the variable x from the two equations. Now to eliminate x or to cancel x in both the equations, we must first make sure that the coefficients of x are same in both the equations. As you can see here, the coefficient of x in the first equation is 3 and the coefficient of x in the second equation is 5. So these two have to be made equal, and that can be done by multiplying the first equation with the coefficient of x in the second equation and by multiplying the second equation with the coefficient of x in the first equation. That means the equations have to be multiplied with the coefficients of that variable in the other equation. For example, here the first equation has to be multiplied with 5, that is the coefficient of x in the second equation, and the second equation here has to be multiplied with 3, that is the coefficient of x in the first equation. So by multiplying the complete equation with 5, we get 3x into 5, that is 15x, plus 2y into 5, 10y equals to 13 into 5, that is 65. And let us multiply the second equation with 3. So here 5x into 3 is 15x plus 3y into 3 is 9y equals to 21 into 3, that is 63. Now as you can see here, by multiplying with the opposite coefficients, we find that the coefficients in both the equations for x have become equal. Now we can subtract the second equation from the first equation so that 15x and 15x gets cancelled, and we can then easily find out the value of y. So let us subtract the second equation from the first equation. So 15x minus 15x is 0 plus 10y minus 9y will be equal to y, and 65 minus 63 will be equal to 2. So very clearly we can understand that y is equal to 2. So this is how, by eliminating the variable x, we can find out the value of y. Now once we have obtained the value of y, we can substitute this in any one of the equations and then find out the value of the other variable. So let us try to substitute y equals to 2 in the first equation, that is 3x plus 2y equals to 13. So if we substitute y equals to 2 here, we get 3x plus 2 into 2 equals to 13. So 3x equals to 13 minus 4, that is 9. So if 3x is equal to 9, x will be equal to 9 by 3, which is equal to 3. So the value of x is equal to 3. So this is how we can solve two equations in two unknowns. The procedure here is, first try to eliminate one of the variables by equating their coefficients, and that can be done by multiplying the equations with opposite coefficients. That means multiply equation 1 with the coefficient of x in equation 2, that is 5, and multiply equation 2 with the coefficient of x in equation 1, that is 3. By doing this, the coefficients in both the equations become equal, and hence by subtracting the two equations, x gets eliminated. And then easily we can find out the value of y, and substituting y in one of the equations, we can find out the value of x. One point which I would like to mention here is, it is not compulsory that we always have to eliminate the variable x first. These two equations can also be solved by first eliminating the variable y and finding out the value of x. And by substituting x in one of the equations, we can then get the value of y. So either eliminate the first variable or the second variable in both the equations. So this is how we can solve two equations in two unknowns. Similarly, if we have to solve for three variables x, y and z, we need to have at least three equations. But as such, in bank exams, we don't get three equations with three unknowns. So let us restrict our discussion only up to two variables in two equations. So very clearly this discussion shows that to solve for one variable we need to have one equation, and that can be done directly in one step. And to solve for two variables or two unknowns we need to have two equations, and that can be done as discussed here. Let us now take some examples based on linear equations. Let us now take the first example from model 1, which is based on solution of linear equations. The question here is solve the equations and establish the relationship between the variables x and y. So as you can see here, two equations are given to us. We need to solve both the equations and establish the relationship between the variables x and y. That is x more than y or x less than y, or more than or equal to y, less than or equal to y, or x equals to y. So as we have already learned, let us first try to solve these two equations by either eliminating the variable x or eliminating the variable y. The two given equations are 6x plus 7y equals to 93 and 3x plus 2y equals to 33. So as we can observe here, the coefficient of x in the first equation is 6 and that in the second equation is 3. So we can understand that simply multiplying the second equation with 2 will make the coefficients of x equal in both the equations. So let us try to multiply the second equation with 2. So this becomes 3x into 2, 6x plus 2y into 2, 4y equals to 33 into 2, 66. And the first equation as it is here is 6x plus 7y equals to 93. Now by subtracting the second equation from the first one, we get 6x minus 6x is cancelled, 7y minus 4y is equal to 3y, and 93 minus 66 would be 27. So very clearly y here will be equal to 27 by 3, that is 9. And once we get the value of y, we can substitute it back in any one of the equations and find out the value of x. So let us try to substitute y equals to 9 in either equation 1 or equation 2. Let us go for equation number 1, that is 6x plus 7y equals to 93. So by taking y equals to 9 here, we get 6x plus 7 into 9 should be equal to 93. So from this 6x plus 7 into 9 is 63 is equal to 93. So 6x will be equal to 93 minus 63 is 30, and therefore x is equal to 5. So the value of x here is equal to 5. So this is how we always solve the two equations, by equating the coefficients of either the first variable or the second variable. Now as you can see here, the value of the variable y is equal to 9 and that of the variable x is equal to 5. Now as given in the question, we are supposed to establish the relationship between the two variables x and y. Here we find that x is equal to 5 and y is equal to 9. So very clearly we can say that x is less than y, since x is 5 and 5 is less than 9. So this is what we are supposed to do in these type of questions. Simply solve both the equations and find out the values of the two variables or the two unknowns, and then establish the relationship between the two variables as x is less than y, or it may be x greater than y, or x equals to y. Let us now take the second example from model 1, which is based on solution of linear equations. The question here is solve the equations and establish the relationship between the variables x and y. And the two given equations are root 36x plus root 64 equals to 0 and root 81y plus 4 square is equal to 0. So as you can observe here, these equations are linear equations in only one variable. So we can directly get the values of x and y from each of the equations. Now the first equation here, that is root 36x plus root 64 equals to 0, can be simplified as 6x plus 8 equals to 0. Why? Because root 36 is equal to 6 and root 64 is equal to 8. Similarly, the second equation here can be taken as 9y plus 16 equals to 0. Why? Because root 81 is equal to 9 and 4 squared is 16. So we clearly observe that each of these equations is a linear equation in only one unknown. So directly the value of x here can be taken as minus 8 by 6 or minus 4 by 3. And the value of y from the second equation can be taken as minus 16 divided by 9. So x equals to minus 4 by 3 and y equals to minus 16 by 9. But as we are supposed to establish the relationship between the two variables x and y, let us compare these two fractions and decide what is the relationship between these two variables. The comparison of fractions can be done in a number of ways, but the best way to compare two fractions would be cross multiplication of the two fractions. Let us understand how to do that. The variable x here is equal to minus 4 by 3 and the other variable y is equal to minus 16 by 9. Now, as per the method of cross multiplication, we simply cross multiply the numerators and denominators of these two fractions. That means the numerator of fraction x is multiplied by the denominator of fraction y, and the numerator of y is multiplied by the denominator of x. So minus 4 into 9 would be equal to minus 36, and minus 16 into 3 would be minus 48. Let us now decide what is the relationship between these two values. We very well understand that minus 36 is greater than minus 48. Remember friends, never cancel the negative signs when we are comparing the two variables in this manner. Why? Because if the negative signs are cancelled, the relationship will be quite opposite to that what we have obtained. So negative signs have to be considered as it is. So minus 36 is greater than minus 48. Why? Because if negative signs are not there, 36 is less than 48. If 36 is less than 48, minus 36 should be more than minus 48. Now whatever relationship we get when comparing these two values, the same relationship should be taken for x and y. So here we can say that x is greater than y. So the answer for this question here should be x greater than y. So this is how we can always compare the two variables by solving the two equations and establish the relationship x greater than y or equal to y or less than y. And one important point that we have understood here is the comparison of fractions. So whenever we have to compare two fractions, simply go for cross multiplication, as that's the easiest way to compare the two fractions. Let us take one more example on comparison of fractions. Let's say we have two fractions, that is 7 by 12 and 5 by 9. Now to decide which of these fractions is greater, what we have to do here is cross multiply. 7 into 9 is 63 and 12 into 5 is 60. As 63 is greater than 60, we can say that 7 by 12 is greater than 5 by 9. So whatever relationship we get in between these two values, same has to be considered for the two fractions. So this is how you can compare the fractions and establish the relationship. Let us now discuss one more example, that is example 3 from model 1. Again, there are two equations which we need to solve and establish the relationship between the two unknowns. The first equation here is 9 by root x plus 19 by root x is equal to root x. And the second equation in terms of y here is y power 5 minus 2 into 14 raised to the power of 11 by 2 divided by root y is equal to 0. So let us now see how to solve these two equations. Now from the first equation, we can understand that the LCM is root x. So the numerator here will be 9 plus 19 and this is equal to root x. So this will give that 9 plus 19 is equal to 28. 28 is equal to root x into root x. We know that root x into root x is nothing but root x whole square. So that can be taken as x. Or otherwise, root x is x power 1 by 2 into x power 1 by 2. So x power 1 by 2 into x power 1 by 2 is equal to x power 1. Why? Because whenever the bases are equal and in multiplication form, the powers can be added. So adding half and half, we get 1. So this can be taken as x power 1. So from this very clearly the value of x is equal to 28. Let us now solve the second equation, which is in terms of y. Here we know that y power 5 minus 2 into 14 whole power 11 by 2 divided by root y is equal to 0. So by taking this on the other side, we get y power 5 is equal to 2 into 14 is 28. 28 whole power 11 by 2 divided by root y. Now let us cross multiply this root y on the other side. So we get y power 5 into root y equals to 28 raised to the power of 11 by 2. Now as you can see here, this is nothing but y power 5 into y power 1 by 2. But because root y is whole power 1 by 2. Now again the bases are equal and in multiplication form. So the powers can be added. So this can be taken as y power 5 plus 1 by 2. As the powers are 5 and 1 by 2 and the bases are in multiplication form, should be equal to 28 power 11 by 2. Now 5 plus 1 by 2 is nothing but 5 into 2, 10 plus 1, 11 by 2. So this is equal to y power 11 by 2, which again is 28 power 11 by 2. So now we can say that 11 by 2 and 11 by 2 on both the sides get cancelled. Why? Because the bases are y and 28 and powers are equal. So they can be directly cancelled on both sides. So here y will be equal to 28. So as you can see, the variable x was 28 and the variable y is also 28. So the answer here should be x is equal to y. The variable x is equal to the variable y. Let us now take one more example from model 1, where we are supposed to first frame the linear equations and then solve them to get the required values. Let us look at the question here. The cost of 4 chairs and 1 table is rupees 3,400. And the cost of 5 chairs and 3 tables is rupees 6,000. What is the cost of 1 chair and 1 table? So in these type of questions, we first need to frame the proper equations and then solve them to get the required answer. Now by looking at the first statement of the question, the cost of 4 chairs and 1 table is 3,400. Let us assume that the cost of each chair is C and the cost of each table is T. So the first equation says 4 chairs and 1 table. The total cost is 3,400. So the cost of 4 chairs would be 4C and 1 table is T. That should be equal to 3,400. And the second equation can be framed from the second statement. That is, cost of 5 chairs and 3 tables is 6,000. So if the cost of each chair is C, cost of 5 chairs would be 5C and 3 tables, that is 3T, will be equal to 6,000. So these are the two equations that we have in two variables, C and T. So by solving both the equations here, we can find out what is C and what is T. That is the cost of 1 chair and cost of 1 table. Now as we have discussed earlier, to solve two equations in two unknowns, we need to equate the coefficients of either the first variable or the second variable depending on the convenience. Here the coefficient of T in the first equation is 1. And the coefficient of T in the second equation is 3. So let us simply multiply the first equation with 3 so that these two coefficients become equal. So that is 4C plus T equals to 3,400 into 3. So 4C into 3 is 12C plus T into 3 is 3T equals to 3,400 into 3 would be 10,200. And the second equation as it is will be 5C plus 3T equals to 6,000. Now by subtracting the second equation from the first one, we get 12C minus 5C, that is 7C. This plus 3T and minus 3T gets cancelled, will be equal to 10,200 minus 6,000. That will be equal to 4,200. So if the cost of 7 chairs is 4,200, we can understand that cost of 1 chair will be 600 rupees. That is 4,200 divided by 7. So cost of each chair is 600. And once we have obtained the cost of each chair, we can substitute this in any one of the equations and find out the cost of 1 table. So by substituting 600 in the first equation, we get 5 into 600 plus 3T equals to 6,000. So very clearly 3T is equal to 6,000 minus 5 into 600 is 3,000. So from this T will be equal to 3,000 by 3, that is equal to 1,000. So the cost of each table is 1,000. So we can say that the cost of each chair is 600 and that of each table is 1,000 rupees. So this is how, based on the given question, sometimes we need to first frame the equations and then solve them to get the required answer.